हेलो दोस्तों, कैसे हो। मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं।
So the parameters, the failure criteria and formula. So first parameter is diameter of rod, and how do we consider which failure we consider? Consider failure of rod in tension. Why we consider failure of rod in tension? Because rod is pulled. So as the rod is pulled, it will fail in tension only. And when it fails in tension, we get the cross sectional area as circle. So the formula written here is P equal to pi by 4 d square into sigma t. First, second we consider diameter of spigot, and diameter of spigot is denoted by d2. And what we consider, which failure? We consider failure in tension. Why tension? Because spigot is pulled. As the spigot is pulled, it will fail in tension. Whichever part is subjected to pull force. Pull force means tensile force. That will fail in tension. So what will we consider a failure in tension? We'll consider failure in tension. And if I draw the shape, then shape will be a circle with a rectangle cut in it. So the area will be pi by 4 d2 square minus d2 into t will be the area. Multiply the area by stress sigma t. Why? Because it fails in tension, and we'll get the strength equation. Then third we find, again here first we check the induced crushing stress. Induced crushing stress. So which failure we consider? We consider crushing failure. And how do we find P equal to crushing failure of what? Crushing failure of the cotter with the rod end. So the formula is d2 into t is the area multiplied by sigma c, and we get here the value of induced sigma c. Sigma c induced is checked. Then next we find diameter of socket. And how do we find this? By considering the socket in tension. And what we get in the area, we get a circle, and in that circle there is another circle, and the area between the two circle is considered, and in that also there is a slot cut. So what will be the area? Area becomes pi by 4 d1 square minus pi by 4 d2 square. So this is the area of both the circle. Okay, so area between the circle minus d1t. d1t means we have subtracted the entire slot. Okay, d1t means we have subtracted the entire slot. See, this is d1. This is what? This is d1. So when I am saying d1t means we are subtracting the entire slot. This thing. But out of which this one is already subtracted. From here to here is already subtracted. Why? Because when we subtracted d1 square minus, when you did this d1 square minus d2 square, so this entire thing is subtracted, and it means this is also subtracted. So what we have to do? We have to then add this plus d2 into t, and this everything into sigma t. So when we modify this formula, what we get? We get pi by 4 in the bracket d1 square minus d2 square minus in the bracket d1 minus d2, and outside the bracket t. Okay, so you can write it either this way, or the way you are already writing, equal to k. Next we find the diameter of socket collar or spigot collar. Diameter of spigot collar. And how we consider this? Which failure? We consider the crushing failure. considering crushing, so P equal to what is the area? It is the area between the socket collar and the spigot collar. Socket collar and the spigot collar. And how much is the area that is crushed? That is the area D3 minus D2. So D3 minus D2 are the two circles. So what we will write here? Pi by 4 D3 square minus D2 square. And this into sigma C. Next we find diameter of socket collar. And here what we consider? Here we consider again crushing. So this socket collar gets crushed with the cotter. The socket collar gets crushed with the cotter. Okay. So when it gets crushed with the cotter, what we see here is the area that is D4 minus D2. Okay, and it gets crushed with cotter, so into T, into sigma C, and this is equal to P. Then 7th is, then we have A, B, C and T1. So we will start with A. So A is what? Distance from end of rod to end of slot, and it falls in what? It falls in shear, and it is double shear, so we will multiply it by 2. And what is the area of rectangle that gets shear? The area of rectangle that gets shear is D2 into A, or you can write AD2 into tau equal to P. Then width of cotter. How do you find width of cotter? Again we consider shear failure. Why shear failure? Because cotter is pulled in both the direction. So upper and lower part of the cotter is pulled in one direction in the socket, and the middle part of the cotter is pulled in another direction by the spigot. So what we will get here? P equal to, what is the area? Area is B into T, and this is double shear, so into tau. You can watch my earlier video which are available, so that whatever I am telling, if anyone has any doubt, he can get it cleared by watching the video where I have explained it with the wooden model. Then we find C. So how do we find here? Here what we got? Here we got D1, then D3. Here we get D4. Here we will get A, then B, then C, and then T1. So C, what is C? It is thickness of socket collar. And how do we obtain it? When we consider the shear failure of socket collar, we get the thickness, and the area that fails in shear is D4 minus D2. It is double shear, so 2 into C into tau equal to P. And last we find the thickness of spigot collar. And this also, spigot collar also fails in shear. And what is the area? It is the area of a ring. So it is pi d2, t1 is the thickness, into what? Tau. So I know now all of you are very much clear with these formulas, how these formulas are obtained, how to remember it. Now for remembering the formula, you know that these first two and this third one, rather the fourth one, this fails in tension. Then from here these two are in crushing, and the last four are in shear, and this one is in crushing, that is induced stress. So you can remember this, either remember this sequence. Now if I talk only about cotter, then where is cotter involved? Cotter is involved in this. See, wherever you get T, you get involvement of cotter. See, cotter is involved here. Then where else Cotter is there? Where you will see B and T. So here there is Cotter. Here there is Cotter. And where else there is Cotter? Where else there is Cotter? Here. Here there is Cotter in sixth formula. That is diameter of socket collar. Is there any other formula where Cotter is involved? Cotter is involved directly? No, only this much. Correct. Now,